Okay, in this video we're going to describe how to develop the basic equations two of the basic kinematics equations from the IB data booklet using velocity time graph. So we have our graph here. It's velocity in meters per second versus the time that the motion occurs under in seconds. Now these can be any units of velocity, this can be any units of time, but the two base units are meters and seconds. Those are what we would prefer. This is the equation we're going to derive. S equals u plus v over 2 times t. And v is your final velocity for the time period. So this is how fast I'm going at the end. And then u is how fast I was going at the beginning. And then this is the time period over which that occurred. Now, for this, we're assuming essentially that the bottom is 0 speed and 0 time. Now, from here, we're going to look at the fact that the distance traveled, the change in position, is going to be the area between the curve and 0. Now, that essentially makes two possible sections. We have a rectangle section here. Right, and that makes this u and this is t, so the area of that, which is equal to the change in position, is equal to u times t. Now the other section is a triangle, which is here, and this is v up top, it's u down below, so the area for a triangle, which is also going to be delta s, but a different s, different distance or displacement from our first one, is 1/2 of the base times the height. That's 1/2 of v minus u. Okay, if this is u, this is v, then this distance is v minus u, and that's a u, not an a, times t. Now, if we want to find the s, again, I like to write the letter delta in front. The data booklet just makes it s, assuming that you're talking about delta or change in position, is equal to both of these parts put together. So ut plus 1/2 of v minus u times t. I can factor out the t, and I can take the 1/2 and multiply it through, and I have delta s is equal to u plus 1/2 of v minus 1/2 of u, and all that's times t. Now, go on another step, then I can say, well, u minus 1/2 of u is 1/2 u plus 1/2 v times t, and that's going to be equal to delta s. Okay, and that's going to leave us with delta s equals v plus u over 2 times t, which is what we have in the data booklet up here. Right? So essentially we've got a trapezoid there, so we'll find the area under the trapezoid. It's kind of like we're taking an average of the velocity, the beginning and the final velocity. We're kind of dividing those by 2 to get an average velocity of this section of the trip right here. Then we're multiplying that by time to figure out how far we've gone. So that's where that comes from. It's a useful relationship, but it has to be a situation where the acceleration is constant. So if the acceleration is not constant, this does not work. Okay, so constant acceleration.